Hello, everyone. My name is Sergey Glazer. I'm an assistant professor of physics and astronomy at University of Alabama. I'm also the org admin for the Machine Learning for Science Google Summer of Code. So our organization, ML4Sci, short, we focus on machine learning, developing machine learning applications for science. So really straightforward. And what we do is we work with real scientists, scientific collaborations all over the world, both to focusing on experiments that take place on Earth, but also sometimes in space. And our goal is to advance them towards potentially some discoveries. So it's a very exciting topic, and we are new, but also rapidly expanding and rather popular organization. And so, to give you an idea of the type of science we're currently doing, we work on particle physics. For example, it means Large Hadron Collider at CERN and other places, where our goal is to see if we can understand, better the elementary particles, use machine learning to identify different types of particles, and so on. We look also in astronomy to try to answer all sorts of questions about the universe, both from the astronomical standpoint, also from a cosmological standpoint. Trying to understand questions like what is dark matter, can we identify it, and so on. Can we figure out what it might be? Can machine learning play a role? Also things like planetary science and so on and so forth. So the main criteria for a project to be part of our organization is to be related to machine learning and science. That's the combination. And over the past 2 years, we've carried out about 40 projects successfully. So they're all great. They all spanned all these different areas and obtained some really cool results. So I'm happy to share a few highlights with you. For example, we built some of the contributors built some of the state-of-the-art results in particle identification for particles at the CERN Large Hadron Collider. Also, some of the first deep learning algorithms were developed to look for dark matter substructure, specific things using gravitational lensing and images that come from the upcoming, also some current instruments and some of the upcoming instruments like the Vera Rubin Observatory. Also, one of the contributors just this past summer has developed and applied machine learning algorithms to identification of exoplanets, and that has resulted now in discovery of an exoplanet. So this contributor is working now with the scientists and publishing that result. We're very excited. You might hear it in the news hopefully soon. Also, we developed one of the first on the area of quantum computing and quantum machine learning. One of the first quantum generative models, one of the first quantum GANs, was built one of the contributors both past summer and also extending this work this summer. So there's a lot of exciting things going on, and and our organization is growing. So many of our contributors, they come back as mentors and so forth. And also we have more projects, more scientists, more experimenters joining our fold. So we welcome more contributors. You don't have to have a science background to do this. As long as you're interested in machine learning, as long as you want to contribute and you'd like to be part of the experiments and contribute to these endeavors, you're very welcome to apply. You can find more information about us in the last slide. Thank you very much. We look forward to meeting you.